Morning, guys. Welcome back. So today we continue with our seven exponential equation. Last time on Tuesday we did some problem already, but I want to give you more example on seven exponential equation because this type of equation it transforms. It doesn't have a specific form for you to study, so you have to make sure that you have to be exposed to different type of exponential equation. The method will be the same. You will have either one, two, or three method. Like last time I already give you. One of them is you using the equivalence property, right? The other one is using the log principle, or and the third one when you have to take log both sides. And at the end of last session, I always recommend to take log both sides. If you cannot convert one base to the other base, then you should take log both sides. And I also mentioned that you can use any type of log. You can use log base 10 or log base natural log. You can use natural log also. But I haven't give you any problem that I have to use natural log. So today, maybe I'm going to use natural log to solve exponential equation. And maybe I will do some problem using log base 10 also. Okay, so last time I used one of the log based on the base of the exponential number. It doesn't matter. You can use any. Okay, but some log is easier than the other. Okay? So you have to pick wisely which one you should use. Okay. Any question for me before we start? Any concern on homework? All right. So let's get started. So I'm just putting here. Let me share the screen first. Okay. Okay. Good. Good. So again, we're gonna put 7 exponential equation. Continue. So please start with your assignment, okay? Don't fall behind. The earlier you start, the easier for you. The more time you have to prepare for the third test and the final, especially final. Okay, so let's take a look at this example. I have 3 raised to the 2x minus 1. I think this color is not really good. I should use black. 3 raised to the 2x minus 1 equal to 0.4 raised to the x plus 2. So you see the left hand side, we have a power number, an exponential expression. The right hand side, we have another exponential expression. So I'm sure that this is exponential equation. No radical involved. There's no absolute value being involved. I mean, I can put an absolute value there, but I mean, it could be very hard, right? And you look at the base on both sides. One of them is 3. Another one is 0.4. And if we think about using the first method, which is the equivalence property, we must be able to convert one base to the other base. Then we set the exponent equal each other, right? However, this is 3 and 0.4. Well, just think about it. It'll take 1 minute to think about how we're going to convert 3 to 0.4 or how we convert 0.4 to 3. One is whole number, the other one is decimal number. Sometimes you can. But in this case, 0.4, if you change it into fraction, will be 4 over 10. 4 over 10, they all even number. There's no way you can convert from 3 to 4 over 10 or from 4 over 10 to 3. So it doesn't work. The first method doesn't work. The second method, which is the priority, you should use for this problem, which is the one you check log both sides. Last time, remember, I take log of base 3. I take the log base based on the base of the power number. So you can take log base 3 over here. You can take log base 0.4 if you want to. But today, I want to take log base e, which is I want to take natural log. So taking natural log both sides. It's just a recommendation, okay? It's just one of the approach. You can use any approach as long as it's logical. So I'm going to take log natural log both sides. Then what it become? Become ln 3 raised to 2x minus 1 equal ln 0.4 raised to x plus 2. So I'm taking log both sides. Then I apply the log property. I can bring the exponent to the front. All right. Same thing here on the right hand side. I can bring the exponent to the front. You know, one of the property we already learned. Okay, if you guys have not memorized the property, make sure you write on a piece of paper, or you can write on a note card, you know, note like that. You know, then you carry that with you all the time, or just a piece of note like this. That's what I have in my wallet. I have a bunch of formula in my wallet. You know, every time before I'm sleeping, I just take a look at that. So that's a good way, you know, to memorize formula, because you have a bunch of formula that's very hard for you to memorize at one time. So each day you just take the note. Oh, okay, I'm going to look at that for 10 seconds before you sleep at night. Okay, that's one of my ways. Okay, so I assume that you know the property. All right, over here again, right? So we have parentheses. I just distributed. I distributed here. Okay, I just distributed. Okay, so after I distributed, I recognize that we have two terms with x. Because we need to solve for x, right? Because we need to solve for x, it means that all the term with x we need to move to one side. So I'm going to move the term with x on the right hand side to the left hand side. You know what I mean when I say move, right? It means you subtract both sides. And I move negative ln3 to the right hand side, I mean I'm adding both sides by ln3. Okay. So far so good. Any questions so far? Now, all the term with x is on the left hand side already. However, our goal is still to get the x. It means that we need to factor the x out. So you have to factor the x out. Okay. On the right hand side, I keep it for the time being. I'm not touching anything. I just rewrite it. Okay. So how am I going to get x? Now I want to get x by itself. So what is the next step I should do to get the x by itself?
Would you divide?
You divide. You divide by what? Divided by what?
Divided by the 2ln3 minus ln.
You divide by that stuff. So you divide both sides by 2ln3 minus ln.4. Okay. And over here, you can leave it as the final answer. But what if you want to test and you have to fill in the blank, right? I don't know how you're going to fill this in the blank. I mean, maybe they have a tool right there for you to fill the blank, or maybe they take decimal number and you're allowed to use the scientific calculator. On on scientific calculator, you have natural log. I believe so. Let me see. I have a scientific calculator here. So, and I have natural log right here. So I just put it in because it's really bad to put it in like this, I mean, you can, but it still depends on if the test take it or not. It depends on how they set up the test. And I don't mind. I love this final answer because it looked more professional to me. But what if the system doesn't want you to take it? Then you have to convert to decimal number. Okay. All right, so I'm going to do 2ln4, so ln.4, so I'm going to put 0.4 and click ln plus 2. So give you, multiply by 2, I'm sorry, now plus 2. So 0.4 ln multiply by 2, give you negative 1.83 plus, now I'm going to do ln3. So 3 ln 1.098 divided by ln3 multiplied by 2, 2.97 minus 0.4 ln, negative, so it becomes positive. Okay, I know it depends on what scientific calculator you have. You can put everything in, but I recommend not. So I just do one by one. So I'm gonna add the top to the bottom. So let's do with the bottom first. 2.197 I'm adding. So give you the bottom is 3.113. Go ahead, try it for yourself, okay? Just in case I have some careless mistake. Okay, so I have 1.83 minus plus 1.098 give you negative 0.732. Then I divide by 3.113. All right, so final answer will be negative 0.235.
I got 3.1132.
I mean, you got something wrong because I checked the solution right here.
No, for the bottom part.
Right here?
Yeah.
No. So 2197 plus 0.916, 3.113.
Yeah, that's what I feel like I got the same thing.
Okay, so right here, 3.113. Okay, that's for the bottom, but you have to do the top and you have to do division. Okay, but this step is not really important, to be honest. Come on, everybody know how to put it into calculator. The important step is right here. Okay, so that's the first example. Okay, so when you solve an exponential equation, you have to consider, you have to say like what method you should use. Second example. I have something like this. E raised to e squared equal 200. Excuse me. So we have 2e right here, and the big E is the base. The e squared is the exponent. So the base right here. You know, usually they're gonna put parentheses for you to recognize easily, but they don't have to. They can throw away the parentheses, but you must be able to recognize the big E's over here. In this case, I'm writing is the base, and e squared is the exponent. All right. Oh, I'm sorry, not e squared. Oh, that's why something wrong. I write it wrong. I'm sorry. This is x. Oh, so that's easy because there's only one e. So the exponent is x squared. I'm sorry. So the base is still e. There's only one e. And every time you see e, you think about natural log. Because natural log is related to e. Right? Natural log is actually not. Natural log is the same as log base e. Okay, so in order to solve this, we have to use natural log. We have to use natural log. And you think about when you take natural log both sides. When you take natural log both sides, you will have something like this. Right? And because x squared is the exponent, it's not just x, but x squared, okay, is the exponent. Then you can drop it to the front. Okay. So then you can drop it to the front. You see that step we use a lot, right? You don't have exponent and then you drop it to the front. You know, in the last example, we do the same, right? You have 2x minus 1 as the exponent, you drop it to the front. Same thing over here. You drop x squared to the front. Most of the
Quick
time.
question.
Yes.
So log base E and log base 10 are not the same thing, right?
No, it's not the same thing. Log
Okay.
base e is the base is e. Log base 10 is the base is 10. It will give you the different answer. Here, I can show you really quick. Let me use the graphing calculator. It's easier for you to see the difference. So, for example, I take log base 10. See, this is log base 10 of 2. It gives you 0.3. But if I take natural log of 2, which is log base e, it gives you 0.6. You see that? I don't know if you can see it right. See, the first one is log base 10. Okay.
Okay, thank you.
Yeah, the second one is natural log. So it's different. Okay. I can do log base 10 to solve this too, but easier to use log base e. All right, so lne, this is 1. lne is 1. So 1 times x squared is x squared equal ln 200. So in order to solve, it's easy. You just take square root both sides. So x will be equal to plus minus ln 200. Okay, and because there are plus and minus, then I recommend that you have to calculate the amount. So I put 200, then I click ln and I take square root, give you plus minus 2.3. Okay, so you have to see that which one satisfy the equation. So you have to plug them back to check. Okay, so check for extraneous. I'm not checking for you. You go ahead and check it for yourself. Okay, so basically you plug 2.3 in here, negative 2.3 over here, and see which one satisfies the original equation. If it satisfies the original equation, then that is your final answer. If it does not, then that is extraneous solution. You don't count. Okay, you throw it away. All right.
I have a question.
Go ahead.
What happened to the L and E on the left side?
Oh, LNE is 1.
Oh, okay.
Remember, LNE is 1. Remember, you have the formula log of base b of b equal 1. One of the property. So if the argument and the base is the same, then it's equal. Okay. Anything else? Any other concern? So far we're using a natural log to solve exponential equation. I will give you another example that I can use log base 10 to solve exponential equation. Okay, let's see. Okay, you can use any log, to be honest. But one log you use will be easier than the other. For example, in the second example here, I use natural log. You can use log base 10 too. Or you can use log any base. Well, still work. All right. How about doing this? So e 2x plus 1 times e minus 4x equal 3e. Let's try to use log base 10 in this case. Okay, let's see if I can use it or not. Most of the time, yes, I can. But let's see.
Is that negative 4x?
Negative 4x, yes. All right. Before we start solving this, we need to simplify a little bit. Because you see that we have two power number with base e on the left-hand side. Then we can apply one of the exponential property we already learned. So we have to apply this formula. X to the n times x to the m equal x to the n times n. So we have to use this property first. So you see on the left-hand side here, it's the same base. It means that I can add the exponent, add them up, equal 3. Okay, so I add them up because I'm using this. Okay, so I simplify a little bit on the exponent part here. So it become e to the 2x plus 1 plus time minus is minus 4x. And I keep simplifying the exponent, so it become e to the 1 minus 2x. Right, 2x minus 4x is negative 2x equal 3e. Okay. All right. It's almost in simplest form. I think that we can take log right now. I can take log both sides. I think we can. But if you're really good, if you can see things, then you can simplify more. Okay. But if you cannot see things, then you can take log on this step. Okay. So I think I'm gonna take I think I'm gonna do both ways so that you can see. Okay, so I'm gonna do both ways. So on the left hand side, I'm gonna just go ahead and start taking log. So I'm gonna take now. I'm not gonna take log base e anymore. Okay, I'm gonna take log base 10 to see what's going on. Okay, so I'm gonna take log base 10. I'm gonna take log base 10 of e 1 to the negative 2x equal to log base 10. And log base 10 usually we don't need to write 10. But I just write it. So this is the same as this. E to the 1 minus 2x equal log base 10 3e. Because base 10 most of the time, well, all the time, they don't write number 10. It's not professional writing log base 10. It's just log. Okay. So this step is the same. I just write in different way. Okay, so again, we have x on the exponent. I drop them down. Okay, then I distribute it. Okay, and I'm distribute. So when I distribute it, I have log base e. I just rewrite it so that you can see clearly. Log base 10 of e, that's what I mean. Okay, then I move the 2x log base e right here on the right hand side. Okay, then in order to get the x, I divide both sides by 2 log e. So you have log e minus log 3e over 2 log e. That's it. And you're done. You can put it into calculator. Okay. That is when you take log base 10 both sides. It works, still works. If you put it into calculator, I'm sure it's give you the same answer. 100% sure. Now, what if you're really good and you don't want to take log both sides? You want to simplify more before you take log. All right, so how am I going to simplify it? Okay. Think about this. I have this, right? Right now, I'm going to just go ahead and divide both sides by e. Everyone's following me, right? I just want to make sure that you follow me here, because I split into 2 different approaches, because each student has different way of thinking. I know it. Some of you really love taking both sides right away. Some of you, okay, I can see that. I can simplify more. Some of you love natural log. Some of you love log base 10. Some of you love log base 3, whatever you want. Okay. But I just want to make sure that you guys follow me. So I'm just go ahead and divide both sides by e. Okay. And over here, e is the first power. So remember, I apply one more time the formula x to the m over x to the n will be x to the m minus n. I'm applying this. So it'll become what? It becomes e 1 minus 2x minus 1. Because I subtract the power. See, I subtract the power. Equal to. Okay, then I simplify a little bit. 1 minus 1 is 0. So I have e to the negative 2x equal 3. You see that? It's much simpler. You see, now equation you have now is much simpler. Okay, now I'm taking natural log ln both sides. So I have ln e negative 2x equal ln 3. Then I bring 2x negative 2x to the front. And ln e is 1. I just say that in the previous example, ln e is 1. So 1 times negative 2x is negative 2x equal ln 3. So in order to get x, you take ln 3 divided by negative 2. And your answer is this. So what do you see over here? You see that if you take an appropriate approach, your answer looks simpler than the other approach one. You see that the answer in this case, it looks longer, more complicated. The answer over here is shorter, simpler, but it is the same. You can put into the calculator and you calculate them out. It is the same. It is the same. I'm not wasting time plugging it in. It should be the same. Okay. But if you can see things, if you simplify your equation, then most of the time you will have a simpler solution. Your solution will be in simpler form. In this case, it's still good. Your logic is still okay. It's still correct. But you see, your solution is kind of I don't know how you're gonna put it in fill in the blank test. But if you have the writing test, if you have writing test and you show me this, I still give you full credit because your logic is so good. Okay. And you see clearly that two different answers, even though it's the same, but it look different. It just look different, but the answer is still the same. Okay. So it's up to you. It's up to you that what approach you should have. It's up to you that if you can see things or not. Because mathematics is very transformative. You have to be flexible. Okay, you have to be flexible. Okay, just logic. Don't do it by routine. If you do it by routine, then it's you cannot see it. You can see the logic. Okay. Don't ever think that okay, because over here I'm taking log both sides and you have to take log both sides. No, don't ever think that. You can be flexible for yourself, but as long as you have a good logic, your final answer is still good. Okay. I mean, there's another approach. I can take log from here. I can even take log from the original question. But I mean, it's gonna take a lot of time. It's gonna be more complicated. Okay, so we have to simplify a little bit. Any questions? I mean, the exponential equation, you see that is harder than the equation you already learned. For example, radical equation, rational equation, linear equation. Linear equation is the easiest one, right? Everybody knows how to solve linear equation. Then you learn a quadratic equation, and then you start learning how to solve a radical equation at the beginning of the semester, right? Then absolute equation, and then and rational equation, different type of equation. Okay, and by the time you reach exponential equation, you already master the order equation. I mean, if you don't master the other type of equation, then it will give you a little bit of hard time. I don't say a lot, but I mean, because you have to keep learning. You know, 3 months is not good for one course, to be honest with you. You have to keep learning and learning every day. Okay. Any other concern here for example number 3? All right. So that is when I'm taking log base 10 both sides, and it's still okay. It worked. And let's see, I can give you something else. Something interesting. Because I say that it's good that you can be exposed to many forms of exponential equation. Some exponential equation is kind of, you got to simplify more things before it reached the simpler form. Let's see. I'm gonna look it up here. Let's see, we can find something. Okay. Something interesting. don't take it every time we have Zoom. Don't take it as the official classroom. You know, just have some fun a little bit. Just you treat it as the you go into the just treat it as you go into the movie theater maybe, or you go to the park and you just have some fun. Don't stress yourself too much. We just have fun. We just have fun. Don't ever think the way every time you do math, you're like you have a burden on your shoulder and you really stressful and oh, I don't get it. That's okay. I mean, you don't get it now. Take time, relax. You know, we're gonna get it later. Or even right now, you know, I'm saying I go through a bunch of examples like this, so maybe some one of the steps you don't get it. I mean, but I mean, when we finish the Zoom session, you open the note and you see, oh, this one I got it already. Sometimes it just come up to your brain like that, you know. No stress, no need. Okay, let's see. I'm gonna pick some interesting equations so that we can solve together. You know, I have to say the simplest form. I already mentioned that, right? In the previous example, in the previous session, I give you 3, 4 example. Now I give you 3 example, included example in the video, so you have a different type of example, different question. And now I just give you something else. And I think that this will help you more. Oh, how about this? Oh, I see something really interesting here. All right. Example 4. How about this? 4 times let me zoom it up because I cannot see it. 4 times 2x plus 1 equal 1/8 2x minus 3. I mean, some of you like look at that was like, oh crap, how am I gonna do this? I have a fraction, I have exponent, I have a number 4 in the front. I never seen this before. Okay, that's okay. I mean, it's just it's a couple of minutes and think. And think. Remember, we have only 2 ways, two method: equivalence, using equivalence, and taking both sides, the log. Now look at the base on the left hand side. I see number 4 in front of base 2. I see 1/8 as the base on the right hand side. And I'm thinking about, oh, look like number 4, I can convert it to 2. I can see that 1/8, I can convert it to 2 also, because look like 8 is nothing but 2 to the 3rd power. And 4 is second square, like 2 to the 2nd power, 2 squared. That's what I can see. Okay. And it's good that we convert it to 1 base so that we can simplify that. We're going to use the exponential property so that we can simplify things. So 4, I convert it to square. 1/8 is 1/2 to the first power. Right? Everybody agree with me? Okay. Now, on the left-hand side, you see that we have the same base. It means we can add exponent. So I have 2 raised to 2 plus x plus 1. See, I'm just adding exponent. On the left-hand side, on the right-hand side, I can flip up the denominator here to the numerator. Do you know how I'm going to do that? How I'm going to bring the bottom here to the denominator? To the numerator, sorry. How can we flip that? This is one of the rules I mentioned in the previous video already. I don't know if you remember that. I even said it on the side. I put it so that you guys can memorize the formula. That formula, you back in the day, you learned it in intermediate algebra. Do you know how we flip them up?
Negative exponent.
Exactly. Very good. Very good. Very good. Negative exponent. And now on the left-hand side, I just combine it. 2 plus 1, 3 plus x. Okay. And now we have exponent raised to another exponent. Then we can multiply the exponent. See, the same formula I mentioned last video, in the last Zoom session. X to the m raised to the n is x to the m times n. So after those steps, you see what? You see that we have the same power. We have the same base. I'm sorry. And because we have the same base, we can apply equivalence property. Because the base is the same now. It's not different anymore. Okay. And the equivalence properties say that we can set up the exponent equal each other. Everyone's following me. Okay. And now you have what? You have a very simple linear equation. Everybody can solve it. Everybody. So go ahead, solve. Okay, so 7x, 6 over 7. Done. Okay. Again, I'm gonna just go ahead and write it, add, subtract both sides. I say that, but I never written down. So some instructor, they treat you guys as the middle school kids. So I don't want you to do so. Somebody who's just like this, add both sides by 6x and blah, you cross them out and something like that. That's fine, but I mean, we don't have to do it. We are professional, you know. We are professional. just do some mental math a little bit. Okay, so you have your final answer 6 over 7, and again you have to check if it is correct or not. If it does not correct, then we don't have any solution. Then when we don't have a solution, you have to put no solution. Okay. And stop me right away if you don't get this. If you don't get any step in this example. Every time you see the parentheses, you just distribute it. I say that 100 times already. And now we just combine like terms that add both sides by 6, subtract both sides by 3. All right. Good. Let's see what else. We still have a lot of time. Oh my God, we have like 15 minutes. But let me see if we have any other form so that you guys can be exposed to. I'm going to give you one of the problem. And you don't have to solve it now, but you just treat it as problem to have fun when you finish the Zoom session with me. Go ahead and practice for yourself. Example number 5, okay? You see that I increased the level. You know, it go from the easiest, then go a little bit harder and a little bit harder. And this one, it seems to be look complicated, but it's not really that bad if you can see things. Okay, and you don't have to solve it now. I just give it to you for you to practice at home. Okay, get some help, do from tutor or just have fun with it. Just have fun with that. No stress. If you cannot solve it, that's fine. But I'm it's not really hard. It's not really dark that you couldn't solve. No, because you apply the same concept. Okay. 81 raised to 5 to the negative 2x times 243 raised to the x minus 2 over x 9 raised to 5x minus 1 equal 1/3.
We can't see it.
Oh, I'm sorry. You see now? All right, so I think we're gonna stop the Zoom session today, and that is my last example. Have fun with that. If you really have any question or any trouble with this example, just let me know. Other than that, next time I'm gonna go through that if I have time. Okay. Otherwise, just skip it there. Have some fun with it. Okay. But remember this: all the knowledge you need to solve example 5. We already talked about it. All the problem is always related to taking both sides, the log, or using equivalence property. Nothing's new. Those are 2 priorities you should try. Okay, but again, you have to simplify a little bit before you try that. Okay, so I think that's all for today, guys. So I'm gonna just go ahead and take attendance really quick. Okay. Any other question? It's my attendance sheet. So today is April 8. Here. Jasmine.
Here.
Emma.
Here.
Lauren.
Here.
Max.
Here.
Natalie.
Here.
Lisa.
Here.
I keep working on your homework, okay? Do not fall behind. Nadia. If you have any concern, just let me know. Nadia.
Here.
Tajani.
Here.
Alberto.
Here.
All right. See you next time. Bye-bye.